Hey guys, it's Vince. Today we're continuing with volume number 26 of CNC controllers built incorrectly. And I want to thank all of you out there, as many of you have given me a lot of positive feedback. And once again, the channel is doing really great. And I'm really happy that these videos are helping you. And mainly I'm talking about the guys that are just getting involved with this genre. And to the other guys out there who once again either leave comments that are sarcastic or just bring negative energy to the channel, I realize that there's really only two reasons that people would be upset for a person bringing forward to light any type of contractor work that is done incorrectly. And that's either because you do work that's incorrect or you're afraid of being exposed of doing work that's incorrect. Now, that being said, my recommendation is deal with it, because at this point, I'm just letting you know, YouTube helps me isolate the videos that I do as breakdowns. And I'm telling you that because the fact of the matter is I get recommended videos, and you can rest assured, whether it's an end user or whether it's the algorithm itself, these videos are done to educate. I'm not putting people down. I'm not showing their faces. I'm doing that out of respect. But the fact of the matter is, most of these guys are not doing any benefit to the algorithm at all, in that they're just publishing content that should be used for nothing more than entertainment and not used for education. That's the problem when we spread misinformation. And I'm going to continue to do this series until the general audience doesn't feel there's any more value in it. Thank you, guys.
I went ahead and I made up a cable.
The content creator is attempting to assemble his own cable, and of course this is a DB25 cable, and many of you are familiar with these connectors. They're more or less a parallel port cable. The issue is, when you're working with these connectors, many of you realize the terminals are very small. And if you're attempting to hold them with your hand like this individual is, then he's attempting to hold the solder. And then, of course, he's not using flux, which again negates the entire soldering process. And I've had some guys say that's a technicality. No, it's not a technicality. It's a fact. Flux is to be used on every solder joint. And we will see this as we go through this video. And the main reason this is number one, safety, so that we naturally have a joint that is considered strong and durable, and also following the direct process of soldering. And on top of that, we want to make sure that the system is stable. We don't want to have connections breaking. And that's the thing I want you guys to think about. It only takes, and I've said this in previous videos, one issue with one connection of all the connections in the system to cause a problem. Think about that. That old saying, you're only as strong as your weakest link, it's extremely true when you're dealing with CNC robotics. There is no such thing as you're being technical or picky. It must be done correctly. That's why it's a precision robot.
We'll be using the step and direction for the first 3 axes.
We hear the content creator, like many before him in my fail video series, explaining to his audience what he's doing. And many of these content creators, when they do that, they have a tonality that comes across like a tutorial. And many of their audience will follow this as a tutorial. And that's where the problems just start. Let's see as we go through this where this goes.
And then I'll be still using the enable signal that's coming out of the acorn. Now the enable signal, I think we have a little bit of inversion there to do, because on one end it's called enable, and on the other device.
This is where detail counts. I slowed the video down to 10% of its regular speed. And I did that because I'm sure most of his audience missed it, because the content creator went very quickly, as may have many of you. He is using shielded cable. Of course, it's single shield. It's not double shielded as it should be. And what he's doing is essentially splicing the cable in certain locations to pull out certain amount of leads he needs to wire in his drives. And you can see that right here. Now, of course, many of you are shaking your head because you realize, as I do, when you work with shielded cable, in order to get those leads out, you have to cut the shield, therefore effectively making the cable ineffective at dissipating EMI, because you've now cut the conductive material, which is once again to be allocated to ground to dissipate EMI. This is why all details count.
So I went ahead and I made the cable and hooked that up to the step and direction on all 3 drives.
You can see by this angle much more clearly the break in the casing where the shielding is once again exposed. The leads have been inserted through the shield, breaking it, and now he's inserting his leads inside the drives to connect the Gecko G251 axis. This is certainly a first in this video series that I've ever seen anyone attach the step and direction leads to their drive and then spin their drive in a circle with the leads attached in order to twine them together. There is absolutely no purpose to this other than to put stress on the leads and also put stress on the terminal block that's attached to the drives. Once again, they're certainly not designed for this, as those leads are very thin gauge wire. We already know that if you're using the proper double shielded cable and it is properly grounded using its allocated ground drain to a ground bus installed within the electrical enclosure of the system, it will dissipate EMI properly. Once again, I have no idea why he would do this. I can't logically come up with an answer other than he thinks he's making things neat. Guys, this is certainly not best practice, and do not follow what you're seeing here. Well, I believe now we know why he did that to the cable is because he's using cable ducting, and we do see that done in a lot of CNC enclosures. But of course, does it make things always practical? I'm not a big fan of it. But again, if you're going to use it, guys, do not do, once again, what you've seen. He is mounting the third and last drive here, and we will see what we have when he's finished. Let's take a look. And you can see right there as he comes up, we'll go from the third drive, the second drive, and you can see exactly where that cable is broken. And once again, the most critical shielded areas of your controller are the step and direction signals, because those are the pulses that drive your motors.
I went ahead and started wiring the outputs then.
I cannot emphasize how poor of an idea it is to use wire strippers on double shielded or shielded cable. Let me paint you a picture. Naturally, these wire strippers' jaws compress the cable and they tear at the casing. And as they tear the casing, the mylar foil, which is basically an industrial form of tinfoil, which is the actual shielding of the cable. In his cable, that's all he has. In double shielded cable, you also have tin-braided copper. The mylar foil is very thin. It's approximately a couple thousandths of an inch in thickness. It will tear very easily if those jaws are too tight. Once again, a content creator doing this in a video really only has 2 reasons to do it. First and foremost is they're trying to save time, of course, to try to get the content completed. The second one is they're totally incompetent to working with this kind of cable and how sensitive mylar foil is to tearing. You guys have to be very, very careful of what you are doing. Naturally, if you got to where he did and you decided to implement these type of strippers and those jaws were too tight, you'd basically destroy that portion of the cable. So be very careful of what you're reviewing. It's also interesting to point out that he's outlined chapters in his video, and each chapter is essentially discussing basically what he's doing step by step. Now, isn't it interesting that we can assume that this is more or less a tutorial video, especially when you consider the fact he's selling as an affiliate all these components in the video? I mean, it's just logical sense that his audience would naturally follow along to this and assemble the system in the same manner they're seeing done right before them.
I'm bringing them down to terminal blocks at the bottom. And
once again, as we discussed in the prior scene, you can see he removed the cable's casing, and in doing so, you now can see the mylar foil shielding is now been destroyed. It's been cut from the crimp of those strippers. Some of you might be saying, well, he was going to remove that portion of the cable anyways. The thing to keep in mind is that where you see that little edge of the mylar foil sticking out above the end of the cable that he plans on using, that also had that same level of stress on it, and you do not know if you're breaking that mylar foil because of the crimping pressure underneath from when it stretches the cable. This is where detail counts, and once again, experience counts, and you guys have to pay attention to these because a lot of times in these videos, the content creator goes by really quick, and most of the time it's missed by the audience. This is really what this tool was designed for as far as being a stripper, is stripping only the leads that are internal of the cable. Because again, the jaws are only then clamping on the exterior casing of these leads so they can't damage any sensitive shielding material underneath a cable's casing. So we see that the content creator, like many before him that make these types of videos, they once again only speak about the details they truly understand. As we see him going through this assembly process, he's detailed enough to wear gloves. Once again, I have no idea why he's wearing gloves. If these components are underpowered, there's no risk of electric shock. There's certainly nothing on them that would require you to wear gloves. We do see the shield drain present on these cable pieces he's essentially making where the drives plug in. And as we watch this, we can see him using the stripper again. He cuts, he strips, and essentially all he's doing is taking that cable and making more and more shield drains that have to be allocated to ground. Now, guys, I did not edit this video to remove the sound on him explaining where he's going to allocate those shield drains. So once again, simply using shielded cable without the allocation of the shield drains does nothing. Makes these cables completely function as if they are unshielded, and in some cases can actually introduce noise into the system. So I'm telling you, we've got to be careful with what we follow.
We're going through now and adding the 48-volt supply.
From this angle, we can see the second drive shield drain is not allocated to a ground bus, nor are the other two drives.
I needed to make up the interface cable to attach the DYN4 AC servo drive.
Here we see the content creator attempting to solder again, and he's building a cable. And we've seen this before in previous fail videos. Many of the content creators simply refuse to use flux or don't understand it. You can see here these connections are not even close to finished. The terminals are not filled properly with flux and leveled. You should have that beautiful chrome finish. I'll insert one of my cables that's assembled, again, a spindle cable. You can see what the terminals are supposed to look like regardless of the size cable you're using, whether it's small gauge wire or larger gauge wire. Those terminals should be filled properly with solder. The other thing to point out is earlier on, of course, he never changed his soldering iron tip. And that's something you definitely want to look at. A lot of these guys tend to use soldering irons that are archaic in age, have never been serviced or cleaned, and you'll see oxidation and black crud on the tip. Your soldering iron, when you're soldering, should be immaculate. The whole idea is that we get a proper bond and we make sure that the flux, once again, is cleaning the terminal as it's applying solder to it. So again, these are very critical steps to assure that the connections are done properly, because I've said this before, guys, the thing about CNC controllers or CNC robotics in general, all details count. It only takes one lead to make you chase your tail, once again trying to correct what is exactly wrong.
To the centroid acorn.
Here's another horrible joint that he just did, and you can actually see the carbon transferring to the lead, which indicates, once again, the lead is not clean, the tip is not clean on the iron, and this will yield an inferior joint.
I built this up following a drawing I received from DS.
Well, here's a topic I haven't discussed in any of the previous fail videos, and that is when a content creator, or anyone for that matter, attempts to solder without using flux, but instead of inserting one lead into the terminal of the connector they're working with, they insert two, whether it's a resistor or another contact lead. Guys, whenever you do that, you're just exacerbating that problem that much more, because then you're attempting to not only join multiple leads in a terminal that's typically only designed for one, but you're hoping that there's enough flux to wet everything and clean that terminal enough that you're going to get the proper fill in that joint. And of course, when you're using two components, meaning another lead or another resistor or whatever component you're trying to solder in the same joint, there's simply just not enough flux built into the solder, and that's exactly what we see here. That's why using flux is so important. Now, I cannot emphasize enough when I hear people say, well, you're being technical. No, I'm not being technical. I'm being correct. You are the same people that would be pissed off if anyone ever sold you a system and that's what you receive. And then people say idiotic things like, oh, well, that's because, we're not professional. No, you don't have to be a professional with that title to still understand the process to do it correctly. If you're serious about building your system correctly, then build it correctly. If you're okay with cutting corners that could potentially affect the stability of the robot or therefore it working in general, then you follow these guys, because again, that's the level of mentality these guys want you to think. A connection is not done just because there's solder applied to it. No different than if a weld is done and just because it's welded, it's done correctly. That's why there's welding inspectors, just like there's quality control inspectors in factories with soldering.
This was fairly straightforward, only thing slightly...
I'm sorry, it's just really comical to see him trying to clean this with a Q-tip when there's no flux being used. I don't know what residue he's cleaning other than he's hoping to remove the carbon deposits from his tip.
Fiddly about it was adding a pull-up resistor between two of the pins. On the electrical panel to put it. And since this resistor is going to be hidden inside the DB25 connector shell, it should make for a fairly neat installation.
We can see the content creator's soldering iron has a massive amount of carbon on its tip. This should never be present, and this once again demonstrates his understanding of this process. The iron should be cleaned after every joint in best practice. We can see that's not being done here. I have well over 400 videos. I cover soldering all over the place. You guys can see it done. Do a search and you'll find it. What you see here with the iron's tip having that black deposit, your iron should never look like that.
That's largely because of the requirements of the DYN4 AC servo drive. The voltage is going to come into the terminal blocks in the lower right corner of the cabinet. It's going to feed the 24-volt DC power supply and then go up the side to provide voltage for both the 48-volt DC power supply and the DYN4 AC servo drive. This is going to keep the high voltage as far removed from all the other components as much as possible. Stepping down in voltage, we have the 48-volt power supply, which is providing voltage to the G251X Gecko drives. And then the output from the Gecko drives feeds down to terminal blocks in the bottom of the cabinet, where they will eventually hook to the stepper motors. We come out of the top of the 24-volt power supply and feed our circuit breakers, and then coming out of the bottom of that, we split off and feed two different banks of terminal blocks, one of those being earmarked for connections inside the cabinet, while the other is for connections outside the cabinet.
All right, now we're in the content creator's overview of their system. Now this is interesting because in every one of these fail videos, these guys typically all do the same thing. They proudly show off the system that they've built, and in all honesty, this system, truthfully, is one of the most cleanest to be presented to his audience. But we're going to break things down in detail because details count. To his audience, once they're blinded with footwork of looking at this, it looks great, like many of the Chinese systems that come from overseas. But when we break down the details, we realize that the step and direction signals that are the most critical signals, once again, of the system to control his motors are not using the proper double shielded cable, number one. Number two, the shielding he is using is ineffective because he did not allocate those shield drains to a ground bus. As a matter of fact, he didn't even identify a ground bus in this system. And I ask you logically to break down a power structure as much as he's done, where once again he's discussed the 220 volt AC, the 48 volt DC, the stepper drive outputs, which once again, just so everybody understands, those are the step and direction signals going to motors to control the entire system. He never discussed anything being filtered or shielded on them, nor did he discuss anything in terms of shielding or ground bus anywhere in this unit other than him separating the 220 volt AC line, which he does have an EMI filter on, but it's interesting to always hear these guys come up with their terminology when it comes to separating things to mitigate EMI. Guys, you can, of course, separate components to mitigate EMI. However, in order to do that, we're looking at least 5 to 6 feet before you start seeing a significant drop in EMI. You're not going to see that within an electrical enclosure within a couple inches of the components that are, once again, sensitive to it. So looking at this, it's really eye candy to see how neat everything is. But when you look at the actual build, that's where things get deceitful. And you understand that the critical details, once again, have not been met. And I really love presenting a system like this because it shows just because it's pretty doesn't mean it's necessarily going to be functional. Think about what I'm telling you.
I currently have the existing corrugated plastic conduit soaking in the purple power degreaser.
Okay guys, this is uncharted waters for the fail video series, as I've never seen a content creator do this before. Many of you are shaking your heads. When you submerge your cables, connectors, and conduit in purple power degreaser, you're subjecting all those connectors and the copper conductors within them to this harsh chemical. Now, doing an open Google search, you can see it right here. It states that this chemical is not suitable for copper at all because it tarnishes. Well, with that layer of tarnish on these connectors internally, which he can't access, basically you're going to create a higher resistance level. That can certainly affect a robot. If he was not going to use these cables again logically, he would have pulled them out. So of course he's cleaning them to once again put them in use with his robot. This is simply something not to do. If you were going to clean the conduit, you would simply remove the cables from the conduit. Once again, don't be lazy. Remove it. Clean what you need to clean, and be careful. If you want to clean the connectors, they sell electronics cleaner for connectors. I don't feel comfortable submerging any cable inside this harsh degreaser when we know that it can actually harm certain rubbers. Now, we don't know if the factory of this stuff ever tested it with cables casings. There's different levels of PVC, and these are things you really want to think about before taking this type of level with a process like this. I think that seeing this, content creators think that I'm saving time, and I've said this before, I want to get my content up. They're not thinking things through in how will this affect my audience. And the thing is, any other guy that does this to his cables, God only knows the results. So let's hope no one got harmed by this, but I'm telling you right now, I would avoid doing this. Clean them correctly. Take your time, use the appropriate cleaners, do your research, and you'll be fine.
I plan on mounting the computer here in the electrical cabinet, so I've ordered some bulkhead connectors that will allow me to pass the USB and HDMI signals from the computer.
PCs are not designed to be installed in CNC electronics enclosures, and this idea has been gone through time and time again by many of these content creators. This one pointed out how many different voltages he's working with. If he really understood CNC electronics, he would understand that all of the devices, once again he pointed out USB, that the PC is using to communicate to, once again, the outside world, is highly susceptible to EMI. introducing all of the power structure of the PC and surrounding it once again with even more EMI makes absolutely no sense. The best thing you guys can do is keep your PC isolated from your CNC electronics. Is it always going to be the most convenient? No, it's not. But it's definitely going to provide much more stability than installing it in your CNC electronics enclosure, on top of the fact it will save you a bunch of money on buying a larger enclosure. All right, guys, that wraps up volume number 26. And once again, to all of those who are serious about investing in the CNC genre, that is why I created this series, so that you know exactly what's fact and fiction. And once again, do your due diligence. Don't take anything I say either. Once you figure it out, you'll come back. It's what happens every single time, and I'm totally confident in it. It's a question of knowing the details. I cannot emphasize that enough. And another quick point to anyone who's bored watching these videos, go back to my other videos. I've got a lot more videos out there on the channel, and on top of that, I'm going to release some new ones. I actually just got in the Hesperos custom CNC enclosure. I'm going to show you guys how that came out because I'm real proud of it. We're well ahead of schedule on that. I know many of you guys always do request for custom components to be made. And once again, this will give you a better idea of what companies are working with now and where they're looking at going. And once again, going from private sector to more of commercial grade engineering. So I want to once again thank you all for your support. Take care.